Hello class, let's review some loops today. Alright, we need to do loops when tasks need to be performed more than once. So my rule of thumb is if I have to do something more than 2 times, loop it. The loop looks something like this in logic. We're gonna go down, check a condition. If the condition is true, we're gonna do something and then go back and check to see if the condition is still true. And we're going to keep doing this process until the condition becomes false, and when the condition is false, we can continue about our program. To create a loop in C#, the syntax is very simple. It's similar to an if statement, except we just changed the if keyword to a while. So while some condition is true, we're going to attach a code block and do some work, and then when we leave the code block, we're going to go back and check to see is the condition still true. And if the condition is still true, we're going to execute the code block and then continue this test. And this test will continue until the conditional logic becomes false. Whenever this conditional logic becomes false, we skip the code block and continue on with our code. Now it's easy to build a loop in C#, but to build a better loop, we need to add some steps. So here I have 4 steps for building a good loop. And then I've modified what the logic block might look like here. So the first step is we want to initialize our conditional variables. Our conditional variables determine whether this condition is true or false. So we need to have some starting values before we test the condition. So we initialize the conditional variables before the loop. Before the loop condition, we check the condition, step 2. Build loop condition, check the condition. If the condition is true, we're going to do the work that we need to do repeated amount of times. So step 3 is do the work. And then step 4, this is the most important step. We need to update the conditional variable. Whatever conditional values got us into a true condition to start our loop, we need a mechanism to change those variables so that there's a way to end the loop. Otherwise, we get stuck in an infinite loop. So updating the conditional variables before we check the condition again is key to building a good loop. This loop, of course, will run until the condition becomes false, at which point we end the loop and continue with our program. Now when we build loops, most loops fall into one of 2 categories. The first category is a loop that needs to loop an unknown amount of times. We can create this loop using a Sentinel-controlled loop pattern. So some examples of where you might use a Sentinel-controlled loop pattern is as follows. Keep prompting the user to enter a password until a correct password is entered. Okay, I need to do something a repeated amount of times, but I don't know how many times the user is going to have to enter this password before they get it correct. So this is a loop that loops an unknown amount of times. We can use a Sentinel-controlled loop to implement this. Enter a number between 1 and 5. Keep prompting until this occurs. Again, I need to do some work repeatedly, but I don't know how long it's going to take the user to enter a valid number between 1 and 5. And then finally, a menu-driven application that keeps running until an exit option is selected. This is a Sentinel-controlled loop. I don't know how long the user is going to be interacting with our program until they decide we're going to hit the exit option and end the application. The other side of things are when you have a loop that loops a specific number of times. You know exactly the number of times you need to loop. When you know how many times you need to loop, we can set up a counter-controlled loop pattern, or we can follow a counter-controlled loop pattern. So for example, input 10 values. If your program needs to input 10 values, you know how many times you need to do the work. We can set up a counter-controlled loop to do this. Or prompt the user how many times they need to enter, and then prompt that many times. So even though I don't know how many this is an example of asking the user how many times we need to do a piece of work. While I don't know what they're going to type in initially, once they type in a number, I will know how many times we need to do the work, and we can set up a counter-controlled loop. So let's outline what these 2 patterns look like when we're trying to create these loops. So here is a basic Sentinel-controlled loop pattern. I like to advise students when you're getting started with loops, just put write this down on a note card, have it next to you, and kind of use it as a framework for setting up your Sentinel-controlled loops. So in this example, what we're going to do is we're going to have our test variable that's going to be changing. Based on this test variable value, this will determine whether we stay in the loop or not. And then we will also have an exit value. And the condition that we're testing is while this test value variable is not equal to the exit value, we're going to keep doing the work. And we're going to do the work, then we're going to update the test variable, get the next value, and then we'll see now does this new test value equal the exit value or not. And so this loop will keep on running until some condition in step 4 makes it so that the test variable has the exit value, and then this condition becomes false and we break the loop. Here we have our basic counter-controlled loop pattern. When we set up a counter-controlled loop, we're just trying to count, we're setting up a counter like a kitchen timer that counts from some start value, counts up or down to an end value by some increment. So I can count up from 1 to 10 by 1s, or I could count down from 10 to 1 by 1s, or I could count up from 1 to 100 by 10s, or so on. So the pattern here is we're going to set up a loop that says, well, while that start value has not reached the end value, we're going to do our work, and then we're going to update our start value by the increment value. This is our clock, right, or our counter. So we're ticking up, we're ticking down here. And then we're going to say, well, have we reached the end yet? And if we haven't reached the end, we're going to do our work again, update the increment, or update our clock, and then, or counter, and then so on. All right. If you notice in these two examples, I'm showing you how to build a Sentinel-controlled loop and a counter-controlled loop using the while loop syntax, or basic loop syntax in C#. There also exists a for loop syntax, which is just an alternate loop syntax for building counter-controlled loops. So in the for loop syntax, we have the keyword for with a pair of parentheses, and inside the parentheses we have 3 statements. We have the initialize statement, that's step 1. We have the loop condition, that's step 2, and we have the update statement, which is step 4. So we have 3 of the 4 steps for building a good loop baked right into the for loop header. And then all we have to worry about is in the attached code block, we do step 3, the loop work. Now the flow through a for loop is as follows. When we enter a for loop, we first do the initialize statement, then we jump over and do the loop condition and test to see if it's true or false. If it's true, we're going to execute the code block, and then we're going to jump out and then implement our update statement. After the update statement, we test the loop condition again, and now we are in our loop. If the loop condition is true, we execute the statements in the code block, jump out, do the update, and so on. Loop condition and so on. This will keep looping until this loop condition becomes false. Whenever this loop condition is false, we break out of the loop, skip the code block, and continue on with our way. Down below, I kind of have our counter-controlled loop outlined if we were going to use a for loop syntax instead of a while loop syntax. Another loop syntax we could use is the do-while loop syntax. The do-while loop is like an inverted while loop. The one big difference between a do-while loop and a while loop is that the do-while loop guarantees we execute the code block one time. All right, so we're going to do the attached code block, and then we're going to check the while statement and look at this loop condition. So we automatically do this one time. If the loop condition is true, we jump back up and execute the code block again, and then check to see if the loop condition is true or false. If it's true, we jump back, do the code block again. And so we're gonna stay in this loop until this loop condition is false, at which point we exit the do while loop and continue on with our code. So notice here the semicolon. The do while loop syntax is the only loop that contains a semicolon at the end of it. All right, we have when we are building loops, we have the ability to exit our loops early. We have 2 keywords we can use. We can use the break keyword to immediately exit and end a loop. And we can use the continue keyword to break out of the loop body but we still remain in the loop. So let me show you how we might use these. So we can use the break statement as an emergency exit from the loop. So for example, here I have a while loop that's running while this condition is true. I could put an extra little condition inside my loop that says, well, if I have some exit condition that becomes true, I hit the keyword break. The break keyword immediately exits from the loop code block. So we would break out of this while loop and we are done. We go on with our code. We can use continue to skip work under certain conditions. So for example, let's say I had a while loop, and let's say below this little if statement I had our key, we were doing some loop work down here. Well, I could set up a condition that said, well, if some skip condition becomes true, hit continue. Whenever we hit the continue statement, we immediately exit from the while loop, but we go back and just check the condition. And if the condition is still true, then we enter our loop again. So break is an exit from the loop code block and we are done. Continue is an exit from the loop code block and we're going to go back and check the condition. And if the condition is still true, we jump back into the loop body. Loops in console applications are very useful for protecting prompts. We can use these loops to ensure that when we prompt the user to give us a menu item or a certain value range or a number, that the values the user gives us are good. We can use it to validate user input. Usually because we do not know how many times it's going to take a user to type in a correct answer or into our input prompts, we can set up a Sentinel-controlled loop pattern to protect the prompt. And that pattern looks something like this. First, we're going to have our initial prompt for some value, and we're going to set up a loop that says, well, while the user input that the user entered is not equal to the good value we are looking for, well, we will prompt again. And this will get the next input value, and then we check to see is the new input equal to the good value or not. And while the user input is not good, we're going to keep prompting. So here's an example of using the try parse method to build a good protected numeric prompt. So here the prompt says enter a positive number. So I want to enter a valid number and a positive number. So there are two conditions I am trying to enforce here, that the user is an integer and the user is a positive number. So I have our initial prompt using the try parse syntax, and now our loop condition is going to say, well, while that user input is not good. Well, the user input would not be good if the value returned from the try parse was false. So I said, well, while parse OK is not equal to true, or while that number that is entered is less than 0, if either of these two conditions are true, that means the input was not good. So the input was not a good value. Then what am I going to do inside the while loop? I'm going to prompt again. And we're just kind of repeating our initial prompt, but maybe with a little bit different wording, so the user knows that they made a mistake on the first try. All right? So this entire code block is an example of a protected numeric prompt. All right, let's test our knowledge here. I have two questions. I encourage the student to read over these two questions, pause the screen, pause the program, pause the video, see if you can come up with some solutions that do this. And in just a moment, I will go over some answers. All right, let's see if we can build a couple loops here. Question 1 says, create a loop that prompts the user, make sure I spell things right, to enter the option A, B, or C, and if the user enters any value other than these, I want to reprompt. So I want to keep doing this work until the user gives me either an A, a B, or a C. I'm trying to validate the user input. So this would be a Sentinel-controlled loop, and let's see what this might look like. All right, so first we're going to do step 1 in building a good loop, which is initialize the conditional variables. And the conditional variable is going to be what the user enters here. So think about it this way. When I'm setting up my loop, I need to determine, well, what will control whether I need to do the work again and again. And in this case, a bad input will determine whether I need to try to get a new input. So the conditional variable is going to be some user input. And so I'm going to build a prompt to get that first input. So I'm going to say console.writeLine. We'll say console.write, enter A, B, or C. And then we'll read in the user input. String input is equal to console.readLine. Now input should, once we run through this little statement, input should either be the string A, or B, or C, or none of the above. Maybe it's kitten, maybe it's a number, who knows. Now let's build our loop condition. Under what condition do I want to keep doing the work? Well, I want to keep doing the work if the input is not a correct answer. So I'm going to say, well, while that input is not equal to A, and that input is not equal to B, and that input is not equal to C. Well, if the user did not enter an A, a B, or C, then I want to reprompt. So we're going to say console.writeLine. Try again. We'll say A, B, or C. And then we will read in the next value. Input is equal to console.readLine. All right. So if we're outlining our steps here, I would call this maybe step 3. The work is reprompting. And when we call readLine the second time, this is where we are updating the conditional variable. Okay, input is our conditional variable. It's the variable that determines whether we loop or not. And so right here we are updating it. We have our 4 steps for building a good loop. This should work. So at the very end, let's after we exit the loop, let's echo what the user typed. I will say console.writeLine. You selected this option. Put a little extra new line at the end. And we'll just print out whatever the user typed. And we'll test it in a moment. All right. Question 2 said, create a program that selects a random number from 1 to 100, then prompt the user to guess the number. If the user enters a number outside of the range, or if the user enters a non-integer, inform the user of these errors. Otherwise, if a valid number is entered, inform the user that the guess was too high, too low, or correct. Keep allowing the user to guess until they guess correctly. So we have a couple things going on here, okay? We have to keep doing work. The work is keep asking the user to guess a number, okay? And so I want the conditional variable in this question is the user's input, the user's guess. That's what's controlling the loop. If the guess is correct, we end the loop. If the guess is not correct, we do not end the loop. We're going to ask again. And so let's try to just set up the basic loop first, and then we will add kind of some of these address some of these features of this loop. So the basic loop might look something like this. Well, I'm going to jump to step 2 where we build the loop condition. And I'm going to say, well, the condition is while some guess is not equal to the secret number. So I copied our little code from the example that describes how I can pick a number between 1 and 100. So this random object has a next method that spits out some random number between this starting value and this starting value. So anyway, our loop condition is while the user's guess is not equal to a secret number. And then what do I want to do? I'm going to reprompt or allow user to guess again. That's the work I want to do. So this is step 3. And then after the user guesses again, we're going to read in the next guess. That's going to be step 4. And then step 1 means when we are initializing our conditional variable, we want to initialize the guess variable. Okay, so I'm trying to illustrate here that even though there's a lot of pieces to this puzzle up here, the basic loop is just a basic Sentinel-controlled loop. We initialize the guess. If the guess is not equal to the secret number, we're going to tell the user to guess again and then read in the next guess. Okay, so now let's start filling in some of the pieces. Well, guess is a number value, so I'm going to use a numeric prompt to get the first guess in. And that means I need a parse Boolean variable with my try-parse. And if you are just jumping into the loop video, I have previous videos talk about how to use the try-parse method. But let's set this up. So I'm going to say int guess, and we're going to create a Boolean parse OK variable. And then we're going to tell the user to guess a number. Console.writeLine or console.write guess a number between 1 and 100. And then we will read in the user input. I'm going to say parse OK is equal to int.tryparse console.readline. Store the result into the guess variable. Okay, so here is our initial prompt. And we're going to say, well, while that guess is not equal to a secret number, but before we can do this test, we need to verify that this prompt that the user guess is actually a number, right? If the user enters in kitten here, parse OK is going to get the value false. So let's build a little loop around that protects this prompt itself. So we're going to say while parse OK is not equal to true, or this is while the parse fails. We could say while parse is equal to false. The reason I use not equal to true is we're following the basic Sentinel-controlled loop pattern while the conditional variable is not equal to the exit condition. So if that parse is not good, we're going to try again. We're going to say console.write, enter a valid number from 1 to 100, and we will copy this line where we read it in. Okay, so what I've done is I've followed that example code from the previous slide that shows how to set up a protected numeric prompt. Okay, here's the initial prompt. While the prompt is not good, reprompt. All right, once we get past this while loop which protects the prompt, now we can get into our while loop that keeps looping while the guess is not correct. So while that guess is not the secret number, well, we're going to tell the user to try again. But also our example code says, our example code asked us that if the user entered a number that was too big, tell the user it was too high. If it's too low, tell them it's too low, and so on. So we're going to say, let's build some conditional logic here. We'll say, well, if the guess is greater than the secret number, then we want to print out too high. Console.writeLine too high. Otherwise, we want to print out too low. Console.writeLine too low. Now, do I need to write a condition that tests, well, if they got it correct? Well, I don't here, because if the guess was equal to the secret number, we would exit the while loop. We would not be inside the while loop. So what happens is when we exit the while loop, I can say console.writeLine correct. Okay. Now the last thing we need to do is get the next guess. So the first guess is not correct. We're going to tell them if it's too high or too low. We need to read in the next guess. This is going to be another protected numeric prompt. So all of this work that I did above, I'm just going to copy this whole chunk right here. Notice I'm copying the initial prompt and the loop that protects the prompt. Okay. We're going to copy all that and paste it in to number 4 here. So I have a while loop inside a while loop, and that's okay. This while loop is protecting the prompt. The outer while loop is looping until the user guesses correctly. All right, let's put a little new line between each guess, and let's check out the result here. First, we're going to check our ABC prompt. All right, enter in the value A, B, or C, and I'm going to enter in some incorrect values. There's a D, another incorrect value, and then finally, if I enter B, we get out of the loop. So the while loop is doing its job. while that input was not A, B, or C, keep doing the work. All right, let's check out our second example here. This is our guessing game. So first we picked some random number between 1 and 100, and now we are at our initial prompt, our initial guess. So we're at this step right here. And it says enter a guess between 1 and 100. If I enter kitten here, it says enter a valid number from 1 to 100. So our first while loop is protecting the initial prompt. We have not entered the game loop yet. We are still just in our prompt loop. So enter a valid number between 1 and 100. I'm going to enter a number 4, and it says too low. Now 4 is a valid number, so try parse return to true. We get past this loop looking to see if the parse fails or not, and now we are in the main while loop here. So for this because it printed too low, it's telling me that what the number that I entered was not equal to the secret number, and that the guess was not greater than the secret number, right? It's less than. So we're going to try again. So now we are at the second prompt. We are at the update prompt inside our loop. We're going to enter our next number. We'll say 50. 50 is also too low, and now we're playing the game. 75 is also too low. 88 is also too low. 95 is too low. Did they guess 100? Wow. First random number it spit out was actually 100. Let's play this game again just to verify that no funny business is going on with the random number generator. All right, let's start with 50. Too low. 75 is too low. Oh, it better not be 100 again. There we go. Whoa, there we go. 88 is correct this time. All right, hopefully this video serves as kind of a reminder of how we do our loops.